Our third experiment is about the bulk unit weight in voids in aggregate. As usual, we start with the purpose, proceed to the theory, apparatus needed, experimental procedures, result, and lastly the discussion and conclusion for this experiment. The purpose of the experiment is to determine the bulk unit weight in voids in aggregate in either a compact or loose condition. Moving on to the theory of the experiment. M is referring to the bulk unit weight of the aggregate. G will be the weight of the aggregate plus the measure, while T is the weight of the measure. V is going to be the measure's volume, and S is the bulk specific gravity that was obtained during our previous experiment, and last but not least, the unit weight of the water will be W. These are the formulas that will be used in our calculation later on. For this experiment, first we need some amount of coarse aggregate which having nominal maximum size of 37.5 mm. Besides that, we also need a balance accurate to 0.01 kg and a 15 liter cylindrical metal tank. In addition to that, a trowel, a tamping rod, and a shovel are also needed. Now we are going to explain about the procedures of the experiment. First, we need to fill the metal tank with water at room temperature. To make sure the tank is fully filled with water, pour some water into the tank slowly using a beaker. After that, weigh the fully filled metal tank on a balance. Empty it and weigh it again. Calculate the difference of the weights and record it as the mass of the water. Then, measure the water temperature and determine its density. As the temperature is 22.0 degrees Celsius, we take 997.77 kg per meter cubic as its density and record it as W. Calculate the volume of the measure by dividing the mass of the water by its density and record it as V. There are two conditions of coarse aggregate needed to be considered to know its bulk unit weight in voids. First, we conducted the experiment for the loose condition. The first thing we need to do is to fill the metal tank with coarse aggregate using a shovel. The height of the aggregate should not exceed 50 mm above the top of the tank. Discharge the extra aggregate and level the surface using the hand trowel. Then weight the metal tank filled with the coarse aggregate and record the reading as G. For the compact condition, first we need to fill approximately 1/3 of the metal tank with coarse aggregate using a shovel. Then tamp the layer of the aggregate spirally with 25 strokes of the tamping rod to make sure it fully compact. Repeat the previous steps until the metal tank is fully filled with coarse aggregate. Discharge the extra coarse aggregate and level the surface with a hand trowel. Weight the metal tank filled with the coarse aggregate and record the reading as G. This is the outcome of the experiment. You can see the weight of each component on the table. For the loose condition, these are the bulk unit weight and the voids in the aggregate that were obtained through our calculation. For the compact condition, we've calculated using the formulas and these are the results. Finally, it's time for the discussion and conclusion part of our experiment. From the experiment performed, we could know that the bulk unit weight of a material in compact condition is greater than the bulk unit weight of a material in loose condition. The greater the bulk unit weight, the less are the voids present and the more is the compaction effort needed. In this experiment, we assume that the temperature of water is same as the room temperature. We was just able to know the room temperature using smartphone, but we didn't measure the water temperature directly. The bulk specific gravity that had been used in this experiment was based on the result in experiment 1 conducted in 10 September of 2019. There was some slightly uncontrollable errors during the previous experiment, so the result as obtained in this experiment is not perfectly accurate. The bulk unit weight as determined in this experiment is not directly suitable for the conversion of mass to volume of the aggregates for the purpose of volume batching, as the degree of compaction in the lab and the construction site may not be the same. That's all for this time. Hope you guys have a nice day.